Hi, everybody. This is Mr. Folly, and welcome to the first podcast of the year. Two things going on right now. One, I'm trying to hold my dog's bone to keep her happy. And I thought I got out my calculator, but I must not have. Did I get it? Oh, yeah, I did. Okay, good. So get your calculators. This is the math world of chemistry. So be ready. Part one, molar mass mole conversions, molarity calculations. So you should know what these are by the end of this lecture. So first of all, atoms are so small we need to think of them as groups. So we don't buy drops of gasoline. So we don't say, I want 65,000 drops of gasoline. We buy about 12 gallons, except the hippie Tesla drivers. Just kidding. We don't want 755 cubes of ice at the gas station. We buy a bag of ice at the gas station. Note these are easy to handle numbers, typically between 1 and 999. So notice drops of gasoline would be 99999999999, and that's too hard to deal with. So keep it small. So paper is small. So how many sheets are on a ream of paper? 500. Hey, that fits my little eyeball here. Bottle rockets are small and sold by the gross. Ooh, let's take a quick little look at this guy. Dun, 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 dun. Oh, come on, play it. Come on, play it. Oh, I bet this is going to be timed out. Oh, good, it still works. No, it doesn't. Oh, here we go. So we're going to watch it on their site. Here we go. Exciting bottle rockets. 10,000 bottle rockets in a minute. Looks like it's a minute 29 to me. I'm going to mute it in case they say bottle rocket nonsense that's inappropriate for school. I don't think they do, except preview this guy. Spin, spin, spin. Look at him. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You guys have never seen this before living in Illinois where it's illegal to shoot bottle rockets like this. But let me tell you, this is a true joy. And it goes on and on and on and on. Look at this. Oh, it gets even better. Look at that. Whoa! But you get the idea. So let's head back to our lecture. Atoms are smaller still than even bottle rockets. Okay. Molecules of compounds are the same. Atoms and molecules are grouped in moles. So remember, the smaller something is, the bigger the group. So notice paper is smaller than a bottle rocket, so they come in groups of 500 instead of 144. So a mole is this monstrosity of a number. And you will see me write it always as 6.02 times 10 to the 23rd, or E23. It is often written as 6.02 times 1023. If you do it this way, it dodges all order of operation things. So this letter E means 10 raised to the. Okay? So on your calculator, if you get out your handy dandy little TI-84 right now, TI-84 plus for those of you who are especially special, and you're going to hit the second comma button and it'll have an E pop right up. Okay, so how many atoms are in 2 moles of sodium? So 2.00 moles of Na. And what I'm going to do is put moles of Na on the bottom to cancel. And I want to put atoms of Na on top because 1 mole equals 6 point, oops, I wrote the wrong thing. I put 2 point. So 1 mole equals 6.02 E23 atoms of Na. And then I get out my handy little calculator. So I can quit to make this thing work. So I'm going to take 2 times 6.02 second comma, that got me the E, 23, and I hit enter, and I get 1.20 E24. I know it says 1.204, but 3 sig figs, given 3 numbers, kick back 3 numbers. 2.50 moles of helium, same deal. I want to cancel moles of helium, and I want to go into, oops, I dropped my magic pen. I want to go into atoms of helium. That's 6.02 E23. And then I'm going to take my 2.5 times 6.02 second comma 23 equals 1.51. E24 atoms of helium. All right. Molar mass, that's the mass of 1 mole of a substance. So it's a cheesy definition, I admit it, but you do have to know what the molar mass is. I call this the go to the periodic table number. So atoms and moles are still pretty worthless units. You can't order moles at, Walgreens or something like that. I want 3 moles of sugar. It tends to be in bags, right, for sugar. And the bags are listed for grams. So we're going to see this. So get out your periodic table, and you're going to see the numbers similar to what we have here. So I've highlighted some numbers here. This is the molar mass of carbon, and this is the molar mass of oxygen. You can tell where all the other ones are. Okay, so to find the molar mass, you just add up the parts and put it in the unit grams. Okay, so carbon is 1 carbon times 12.01 equals 12.01. And I have oxygen. Let me write it this way. Carbon equals, and oxygen equals 2 times 16.00. It's going to be 32.00. When I add those two up, I get 44.01 grams of CO2. So that's it. So fluorine is 19. So fluorine times 2 is 38.00 grams of F2, which is 19 times 2. Neon, notice there's just one of them. So it's just 20.18. And that's it. Converting grams to moles and moles to grams. I kind of did a conversion already, so this explains our conversions a little bit. Conversions are set up to cancel units, okay? So notice if I had this math problem, I could cancel 7s, and they would go away, right? If I had this problem, notice 3 and 3 would cancel, and multiplying by 3 over 3 times 3 over 3 is the same as multiplying by 1. So there's no change at all. As I like to say, it's like kissing your sister. So the value is still the same, but we can change our units this way. So here's our conversion. Convert the following. We have 3.50 grams of NO2 to moles, given 3.52 grams of NO2. I want to cancel the bottom unit, so I put grams of NO2 on the bottom to make it cancel. And I have to have, and I go to the periodic table to get that grams. And these have to equal each other. 1 mole of NO2 equals 46.01 grams. So the only unit I have left is moles of NO2. So that means I get out my calculator, 3.5, the stuff on the bottom, 46.01 is going to be divided by, so 3.5 divided by 46.01, and I get 0.0761 moles of NO2, 3 non-zero numbers. All right. So we're going to do this one from scratch without these words getting in our way. 0.550 grams of H2O, and I'm going to moles, times dividing bar. I want to get rid of this grams of H2O. And you'll find that the thing you can convert everything into and out of is moles. So you're going to hear me say a whole bunch, always go through moles, always go through moles, always go through moles, always go through moles, always go through moles. And we're going to find that the number for moles is 1. It's the big equalizer here, okay? So 0.55 and then times 1. And multiplying by 1 doesn't do anything. So I'm going to take 0.55 divided by 18.02. And this I got from going to the periodic table, right? Hydrogen's 1.01 times 2, and I have oxygen. 0.55 divided by 18.02 is 0.0305 moles of H2O. Ooh, meanness here, okay? So how many oxygens do I have here? 2 times 3 is 6. So let's do this one. 23.0 grams BaNO3 taken twice. And I want to go to moles. So getting out my periodic table. Uh-oh, I don't have one handy. So I'm going to ask my phone what the molar mass of barium is. Oh no, I have my phone. I think it's 137 point something. What's the molar mass of barium? Molar mass. Oh, it just gave me barium. What is the molar mass of barium? It's 137.37. So 137.37 plus 2 nitrogens. So each nitrogen is 14. So 28.00. These are my n's. And then I have 6 times 16. Again, this is 14, 137.37, and 16. So 16 times 6 is 96. Oh, this is 28.02. We always want to pull 2 decimal places. So let me add all that up. So I've got 96 plus 28.02 plus 137.37 is 261.39. That's grams of barium nitrate and 1 mole of barium nitrate. So notice how we mixed all those guys in there once. We got some molar masses. We got all that. We got to divide by the numbers on the bottom. So 23 divided by 261.39 is 0.0880. Is that right? 880, yep. Moles of BaNO3 taken twice. And then if I want to go from moles to grams, if I have 10.500 moles of LiCl. So lithium is 6.91 and chlorine is 35.45. So I hate you moles. Now notice this time it's a little different. I hate you moles. To cancel moles, I got to put moles on the bottom. So I'm going to put grams of LiCl on top. 6.91 plus 35.45. It's 42.36. So 10.5, I don't know why I put so many decimal places on there, but I did, times 42.36 is 444.8 grams of LiCl. All right. I'm going to do 2.55 moles of CH4 quickly. 2.55 moles CH4. I'm going to go to the periodic table and 16.05 grams of CH4. Whoops. That looks like Cl4. So again, notice how moles cancel. So it's 2.55 times 16.05 divided by 1. And I get 40.9 grams of CH4. All right. Concentration of solutions. Okay. Light versus dark. Light Kool-Aid versus dark. Dark is called concentrated. Light is dilute. And concentrated means lots of solute. And solute's just the stuff in it. Okay. We can measure this better with chemistry, right? So how dark, how light, all these other things. Mole, MOL, is the abbreviation for moles. Worst abbreviation ever. Big M is molarity, which is the unit for concentration that we use. V is in volume, but it must be in liters, not in milliliters. So, reminder, to convert from milliliters to liters, we have to move the decimal 3 places to the left. So 50 milliliters is 123.050. 3.5 milliliters is 123.0035. All right, so we're going to use moles equals MV here. What is the molarity of a solution? With 200 milliliters, 3 moles. So moles equals MV. 3 equals molarity times 0.2. Molarity equals 3 divided by 0.2. 3 divided by 0.2, which is 15 molar, which is outrageously high. 15.0 molar. Outrageously high, and a bad problem by me because that's a nonsensical unit. It's too much stuff, but that's okay. We'll roll with it. Most questions are annoying, and they give you grams and milliliters, not moles and liters. So get ready for it. We got to compound this even more. What is the molarity? Oh, whenever I see a molarity, I'm going to do moles equals MV, and I'm going to do it. Of a 50 milliliter solution, shut up, 50.050 liters, with 10 grams of barium nitrate in it. Oh, you evil dog. I got to convert 10 grams of barium nitrate into moles. And then I have molar mass of barium nitrate up here. So if you've got it, let's use it. 261.31. 10 divided by 261.39 is 0.0383 moles of BaNO3 taken twice. So we got moles equals MV. 0.0383 equals molarity, and then volume is going to be 0.05. Molarity equals clear. So I'm going to use second answer. That same one, even though it's got more decimal places, that's the best way to do it. Divided by 0.05. And there we have it. Diabetics sometimes need sugar when their sugar crashes. I know it's weird. Usually say they have too much sugar, they have too much sugar. But every once in a while it crashes, they need some. They have like mints and things like that. I don't know much about it, but I hear this is the truth. How many liters of 0.75 molar sugar can be made with 945 grams of sugar? Okay, so again, I see molarity. I do moles equals MV. I've got my molarity. Oops, I've got grams of sugar. So let's change it into moles. 945 grams of sugar. This is sugar. C12H22O11 times grams of C12H22O11. Okay, a little molar mass fun right now. I'm going to cancel these grams and go to moles. So carbon on the periodic table is 12.01. So 12.01 times 12 is 144.12. This is the carbon part. Hydrogen is 1.01. 1.01 times 22 is 22.22. And oxygen is 16 times 11. That's 176. So I'm going to add all those up. 22.22 plus 144.12. I get 342.34. So 945 divided by that second answer will give me 2.76 moles. So remember, moles equals MV. 2.76 equals 0.75 times V. V equals 2.76, so that second answer, divided by 0.75. And this comes into a spot where we're going to talk very quickly about rounding. Okay, you get plus or minus 5% and give 3 non-zero numbers, and we'll be sweet happy. Okay, and that'll be good enough for our rounding. Okay, that's it. That's fun. That's the intro to moles. Toodle.